This is not an easy integral. I saw somebody using very nice methods on YouTube, and it's well done. Here I have a little different method, so I would like to share with you. I define f of a as an integral 0 to half pi cosine to the power of a. So this is my f of a. I tried to use f of a to find my integral I. Now, if we take the derivative of f with respect to a, then here x is constant. So cosine x to the power of a is kind of an exponential function. And this will be equal to cosine power of a multiplied by log cosine x, right? Because cosine x is constant. Yeah, if you take second derivative, then just repeat again. This is constant. This derivative is equal to cosine a times the log cosine. So it becomes cosine ax and the log cosine x squared dx. Okay, when a equals 0, this is my target integral. So my I is equal to second derivative of f at 0. So this is my idea to find this integral. Okay, so now it becomes a matter of finding f of a. Instead of doing this integral, we are looking for the f of a. Okay. Now I start with this. I start with this integral, sine mx cosine nx dx. This integral is equal to 1/2 beta function of m plus 1 over 2 n plus 1 over 2. Okay, that is a beta function. And if m equal to 0, n equal to a, then this integral it becomes exact cosine to the power a is a dx, right? That is my f of a, which is equal to 1/2 of 1/2 b, sorry, b 1/2 and a plus 1 over 2. Yeah. And we know that the beta function is related to the gamma function. So this is 2. This is gamma half. And times gamma a plus 1 over 2. Over gamma, this plus this is half. And a plus 2. Right? Very good. Now, what is it? What is gamma half? Gamma, well, gamma, what's gamma? Gamma is this. Gamma of x is integral t to the negative x e to the negative t dt, right? That's gamma function. Yes. And therefore gamma half is equal to integral t to the negative half e to the negative t dt. While this is not difficult to integral, we let t be u square So this is equal to, yeah, this is not changed. This will be equal to, this will be t replaced by this is a u to the negative 1, right? Good. E to the negative u square, yeah. Dt will be 2u du. So u cancel out, become a 2 integral e to the negative u square du. Here, this is Gauss integral, 2 times half. So equal to root pi. So my gamma half is root pi. So this is equal to 2 root pi, okay, times gamma a plus 1 over 2, and this is a plus 2 over 2. Very good. Okay, this side is equal to what? F of a, right? So this is my f of a. This is f of a. So f of a is this. Now I take log both sides, log of f of a, log this equals log of that, right? Log of this becomes a log root 2 over 2, that is this one, plus uh, log gamma a plus 1 over 2, and minus log gamma gamma a plus 2. It's confused. Yeah, that's better. It's better. Now then I take a derivative of both sides with respect to a. I differentiate both sides with respect to a. So this side will be equal to f of a, right? And the f derivative of a. Yeah, that is this derivative with respect to a. And this derivative is 0, right? And this derivative is equal to digamma of a plus 1 over 2, right? Since it's half a, right? Using chain rule times 1/2. Minus this one, take a derivative, becomes a digamma of a plus 2 over 2. Then the chain rule times 1/2. Very good. Okay. Digamma is this derivative, right? This will be 1 over this times the gamma derivative. Well, anyhow, it's a definition of a digamma. Now, then I take a derivative again with respect to a. So this one derivative with respect to a, it will be quotient rule, right? F of a squared. Wow. And this derivative, which will be double prime of a times the denominator f of a minus this one times this derivative. So it becomes f prime of a square. So this is the derivative. This is the derivative of the left-hand side. And the right-hand side is equal to 1/2. This derivative is trigamma of a plus 1 over 2. That chain rule again times half minus, this is 1/2. This derivative is trigamma a plus 2 over 2 times this derivative with respect to a, sometimes another half. So this side is equal to 1/4 of trigamma this minus 1 trigamma 1/4, sorry, a plus. Okay, this is equal to this. Now I can find f double prime. So my f double prime of a is equal to, wow, this will be here, okay. This one time this, right? And move this one over there and divide by this. That will be, okay, so finals divided by f of a. And this move over this will be positive. This move over there. And this one time this one, right? And the plus this f of a squared times this, multiplied by 1/4 of trigamma minus 1/4 of trigamma a plus 2. Wow, it's good. Now we are looking for f double prime of 0, right? Aren't we? We're looking for this. So my I, which is f double prime of 0, we just replace a by 0, so f of 0. This will be f prime of 0 square plus f of 0 square multiplied by 1/4. I'll take 1/4 out. Okay, that's better. Yeah. The trigamma of a, no, 0, right? It becomes 1/2. Sorry. Minus 1/4 is out. This is 0. So trigamma 1. Yeah. Good. A equal to 0, right? Which is 1. So finally, this is our target integral. Now we just need to find those zeros. Okay. So first, what is the f of 0? F of 0 is easy. F of 0. This is f of a, right? F of 0 is this is dx, right? Half x. So this becomes half x. Okay, no problem. Now f f prime of 0. f prime is this, right? This is f prime. F prime of 0 is, this is 0, right? So it becomes a log cosine. Log cosine x dx. Well, this is the same thing as a log sine, yeah? Because it's log sine, log cosine, no difference in it. I have a video to find this for log sine, which is equal to negative 1/2 pi log 2. What? Okay. This should be okay. Now, what are left? We need this. We need that, right? Yeah, we need this. Trigamma of a half and a trigamma of a 1. Trigamma half, we're using this trigamma of x is equal to sigma k from 0 to infinity and x plus k to the square over. See, that is a trigamma. So this is later, okay. Trigamma, trigamma of 1 is equal to sigma k equal to 0, 1 over k plus 1 square. Yeah. So that is pi over 6, right? That's a Basel. Now, for this, we're using another formula, which is trinomial x plus trinomial of 1 minus x is equal to pi square sine pi x. Well, we have quite some formulas for those gamma and beta functions. So when x equals to half, so this half plus this is also equal to half, right? Is equal to pi square sine half pi half pi half pi square. So this equal to this becomes pi square. So this equals half pi square. Wow. Okay. See, then all those things are ready. So my I, which is equal to double prime over 0. So we just plug those value. This one is equal to this one is equal to this one is this, right? So this square is equal to pi square over 4 times log square 2. That is this square. And plus f of 0, f of 0 is half pi. So it becomes quarter pi square. Times 1/4. Times this one is this one is pi square over 2. This is a pi square over 6. And f of 0 is half pi. Yeah, f of 0 is half pi. Then, well, we simplify it and becomes this. Log square 2 plus x cubed 24. See, this is my very answer to this integral. Where that to this integral. Okay, I think this is not an easy integral, but it's a nice method. Now we can. I think we can explore, for this log cosine cube. Well, we just take the third derivative. When you take third derivative, it comes up this one. But it's very complicated. But it's theoretically this is a method. Thank you.